Okay, so I'm gonna share my screen on chapter 19, then we'll talk about it on the other side. Okay, uh, can you guys see my screen?
Yes, I can see it.
Okay, yes. So thank you. So we're gonna be talking about the quantity theory, inflation, and the demand for money. So this kind of like continues with the money chapter of chapter 3. We jump into chapter 19. For some reason, I don't know why the author of this textbook, um, put this chapter very late on. It should have followed like chapter 4. That's why I want to cover them at the same time because they're all related to money. Since we talked about money with the money chapter last week. So here's going to be the preview of what we're going to be doing. So this chapter is going to examine the quantity theory of money and the link to the demand for money. We're going to talk about the demand and supply for money. And then we're also going to talk about the link between interest rates and the demand for money, okay? In particular, we're going to talk about two main theories that economists put together to explain why people demand money. We're going to talk about the classical theory for the demand for money, which is in itself that quantity theory of money. Then we're going to talk about the model theory that was put forward by John Maynard Keynes, the Keynesian theory of money demand. We kind of compare and contrast the two theories. So the learning objectives are we're going to assess the relationship between money growth and inflation in the short run and long run, as implied by the quantity theory of money. What we're going to be doing here is that we're going to see that if the central bank, or like the Federal Reserve, increases the supply of dollars to print money all the time, that is going to result into inflation. So we're going to use this simple theory to develop a model of inflation, which shows that money is a main primary cause of inflation. If you increase the growth rate of money supply in the economy, the result is inflation. Prices of goods are going to rise on you. And then we're also going to identify the circumstances under which budgetary deficits can lead to inflationary monetary policy. So the idea here is that if you have a government that wants to finance its budgetary deficit, the deficit is basically when government wants to spend more dollars than they have in tax revenue. Typically, when the government is in a budgetary deficit, as I showed you last week, the government typically borrows money by issuing what? Issuing treasury bonds. But in some other countries, especially developing countries, the government sometimes actually just resort to printing money to pay its bills. So we're going to see that if the government resort to printing money to pay its bills, something that we rarely do here in America, that will result into inflation. And then we're going to summarize the three motives underlying the liquidity preference theory of money. So the liquidity preference theory is basically the Keynesian theory of money demand. Okay, we'll talk about Keynes argues that there are three motives why people demand money. He talks about the transaction motive, that you demand money because you're going to use it for buying goods and services. It talks about the speculative motive. People can hold money relative to other assets. If other assets are going up in value, since money doesn't pay you any return, then people are going to hold less money. They're going to demand less money because they want to invest in like bonds, stocks, which might pay them a higher rate of return. So we'll talk about that. And then, of course, the precautionary motive. People going to keep money to take advantage of the unexpected declines in price in the economy, so that you have money, you can buy things cheaply, or basically money to take care of unexpected scenarios, like if you get sick or something happened to your family, you want to have some ready money that you can help your family. Okay. And then we're going to talk about identify the factors underlying the portfolio choice theory of money demand. And then we shall assess and interpret empirical evidence. But we may not do this, the last one, because this one requires data and some kind of computer programming. Okay, anyway. So let's kickstart things here. Let's start talking about the quantity theory of money. This theory was put in place by some economists out of MIT, okay, many years ago. Okay, they trying to relate four different economic variables here. So we're going to define M. You see M there. M is going to be the total stock of money that exists in the economy. That's our money supply. Like we talked about M1 last week on Friday. the total amount of money that exists in the economy. And then P is going to be the general price level. So this is this class is kind of tied to macroeconomics. So when we talk about price level here, we are not particularly talking about the price of one good, like the price of gasoline. We are talking about the average prices of all goods and services in an economy. The general price level, when we average all prices of goods and services, especially goods that are typically purchased by consumers, then that's what we call the general price level, okay? And then Y is going to be your aggregate output, which you can also call it what? This Y can also be called real GDP. So aggregate out the total amount of goods and services in real terms that the economy has produced. And then if we multiply Y by P, this product of P times Y, that is what we call nominal income or nominal GDP. Okay? Because nominal GDP is a market value in dollars of all final goods and services produced in the economy. Okay? So, these economies develop a relationship between these four economic variables. So, and then V, we're going to have some variable called V, which is the velocity of money. The velocity of money is basically the average number of times that each dollar bill is spent, or you could say the average number of times that a dollar bill changes hands. Like, think about a case where if you went to your bank and your bank issues you a brand new dollar bill, you may go to a convenience store and buy something with it, maybe a pack of gum with it, and then the owner of that convenience store might use that same dollar bill and pay their employee. Their employee is going to go and spend that dollar bill in Walmart. Okay, Walmart might use that money to buy some raw material goods coming into Walmart. So that dollar bill is going to change hands several times. It's going to travel. So if you picture it, if people are not spending money, let's say you receive a dollar bill and you put it in your wallet and you say, it's mine now. You don't want to spend it. Then the velocity of money is going to be very low. But if people are spending money rapidly in the economy, where anytime you receive a dollar bill, you buy something with it, and then somebody who received that dollar bill also buys something with it, that dollar bill is going to change hands several times. Could change hands even 100 times in a year or in a period. Okay? So we are going to say, we're going to do some relationship here. So think about it for a second. If velocity is the average number of times that each dollar bill is being spent in the economy, we can use that concept of velocity to measure, to measure how, relate that to the total volume of transaction that takes place in an economy. So I'm going to open a slide here, then I discuss on it on the other side. And as I told you guys the other day, you guys, you gotta be careful with my handwriting on this. Is not very pretty with this digital pen, so sometimes it might look like chicken legs. But I hope you should be able to follow me anyways. So what I'm gonna do here, I'm gonna try to discuss what that velocity is. So what we're saying is that if M is the total money that exists in the economy, let's say this is like $10 trillion that people are going to be using this money to buy goods and services, okay? And then what are they going to? They're buying Y. Y is the output that people are buying with. Let's say just PY, because normally that's the total value of goods and services in the economy, okay? So that means velocity is going to measure, if you take the total amount of goods and services, the value of all goods and services that Americans are trying to buy with their money, and we divide that by the amount of money that exists in the economy. This is going to give you this velocity. It gives you an estimate of how many times each dollar bill has been circulating in the economy or has been spent in the economy. Let me repeat that again. Because P times Y, that is the total value of all final goods and services that we are producing in the economy in dollar terms. Let's say this total value of goods and services is like $20 trillion. And then let's say that the M is, let's say, $2 trillion. So if you divide $20 trillion by $2 trillion, you're going to get velocity is going to be like what? 20 divided by 2, that's going to be like 10. Okay, so that means each dollar bill would have exchanged hands 10 times. So it's a very simple formula. Yeah, and it's true by definition. So now think about it. So if we're saying, if we say that, you know, V equals to P times Y, and this is true by definition, then we can write what we call, classical economists are going to call the what? The equation of exchange. So when you say velocity equals to Py over M, let's use an example. We're saying that suppose Py equals to $20 trillion. That's what we say. And M equals to, like, say, $2 trillion. Then that means velocity is going to be equals to Py over M, which in this case is going to be $20 trillion divided by $2 trillion. So the dollar sign is going to cancel, trillion is going to cancel. So 2 goes there, 10. So that means velocity equals to 10, meaning that each dollar bill circulates in the economy 10 times on average. Okay? So this is going to allow us now to get the complete relationship, which is very easy to write here. Hold on a second. I got to open a new slide here. So when we say V equals to Py divided by M, we can now cross multiply this. We cross multiply M times V, that's going to be MV must equal to Py. This equation is true by definition. This is what we're calling the quantity what? The quantity equation. So think about it for a second. If P times Y is the total value of all final goods and services that we are producing in the economy, those goods are produced and put in stores like Walmart, like Target, Home Depot, everywhere. And then, so that means if $10 trillion exists in the economy, people are trying to use money to buy those goods and services. And then, so every time a dollar bill is spent, let's say somebody buys something in Walmart, Walmart might pay the employee who will use that same dollar bill to go and buy something out of Home Depot. And the dollar bill. So if you multiply the total amount of dollars that exist in the economy times the average number of times that each of those dollar bill is being spent, that should roughly give you an estimate of the total value of goods and services that we're using our money to purchase. That's why this equation is going to be true by definition. It's an identity. Okay, let me say that again. The left-hand side of this equation is M times V. That if we multiply the total amount of dollars that we have in the economy times the average number of times that each of those dollar bills is circulating in the economy for purchasing goods and services, that should roughly give us the total value of transactions or the total value of all goods and services that we're trying to use our dollar bill to purchase, which is a PY. So MV must equal to PY. That's true by definition. So when we develop economic models, like this is a simple model, we tend to make simplifying assumptions. Okay? So under this classical theory of money, we are going to assume that velocity is fairly constant. In the short run, assumption that we're going to be relaxing once I start talking about the Keynesian theory of money demand. Because under Keynes argued that velocity is not constant. But the classical theory is saying that velocity is constant. So that means, what does that mean when you say velocity is constant in the short run? It means that if the average number of times that a dollar bill changes hand in society, in economy, is 10 times this year, it's most likely going to remain 10 times next year, the following year. So velocity doesn't change in the short run. Okay, it stays the same, fairly constant. And then we're going to assume that aggregate output, which is Y, is at full employment. Remember Y is what? Is output. So full employment, according to economists, is the idea that when all our resources are fully engaged, the maximum that we can produce of GDP, of output in the economy, is what? When we fully engage our technology and resources available in the economy, like labor, capital, natural resources available, the maximum output that the economy can produce is going to be equal to Y. That Y then become what we call full employment. Another name for full employment is also called potential output. Okay. Some people also call it long-run output. It means the same thing. When we say the economy is producing in the long run, it means the technology and a country's resources have already been maxed out. That's the best you can do with your available resources and technology. So you can call it either full employment or potential output level or long-run output level, okay? So that means printing money will not change the ability of a country to produce goods and services. Once the economy has already exhausted all its resources and technology available at that point in time, that means the maximum you can produce could be maybe this Y that we're calling the full employment. So whether you print money, printing money will have zero effect on this Y once you already reach the what? Full employment. Okay, so when we say that, let me open a slide and talk about it on the other side. I'm going to open this new slide here, and now talk about this relationship. Okay, so there's a way when we say velocity is constant and output is at full employment, meaning the output is kind of constant. We're going to put a bar on velocity. We're going to say, when you say velocity is constant, we write like this. We're going to say V equals to V bar. And anytime I put a bar on economic variable, it means its value is constant. And then you could also say, Y, because output is fixed at full employment, it must also equal to Y bar. So that means if I write the equation of exchange, which is MV equals to PY, since velocity is constant, I'm going to put a bar on velocity and I put a bar on Y as well. So according to the classical theory of money, if GDP is rated at full employment, meaning printing money does not change output, and velocity is constant, it means an increase in the money supply here is going to trigger an equal increase, what? Equivalent increase in the price level. So what does that mean? If the central bank, like the Federal Reserve, doubles the money supply, let's say the total amount of money in the economy was $2 trillion. If the Fed, and they say the price level is 2, if you double the money supply from 2 trillion to 4 trillion, it means price is also going to double from 2 to 4. Doubling means you multiply by 2. You know that. If you increase the money supply 3 times, okay, by 3-fold, price level is going to increase by 3-fold. So there's a one-to-one relationship between money supply and price level in the economy, according to this simple classical quantity theory of money. Okay, let's do a simple example to kind of talk about it. I'm going to give you numbers here, and you see what I mean by when you change the money supply by a certain proportion, price is going to increase by the same proportion. So let's pretend and say, just a simple example. Let's say, suppose our M was 50. And let's say the price level was 2. Okay. And let's say velocity was, say, let's pick a number. Let's say 2. And let's say real GDPY was 50. Okay, so you can see, so initially, when you say MV equals to PY, you can see this equation is going to balance, because if this M is 50, you're multiplying it by velocity, which is 2, that's 100. Right-hand side is also going to be 2. Price is 2 times output is 50. So you see, 50 times 2, 50 times 2, so 100 equals 100. Now, let's suppose the Fed, the central bank, doubles the money supply. Remember, we're saying that the economy rates at full employment, meaning that increasing the money supply will not affect the what? Output, because you're at full employment. And velocity, we're assuming that is constant. 2 is going to remain 2 forever. Okay, so suppose M is double. If M is what? Now 100. That means the price level is going to increase to 4 if you do the math. So if you're calculating a new level of price, that means M times what? So M times V equals to PY. So now M is what? 100. Velocity does not change, is 2. So the price level, we're solving for the new price level. Output has remained at 50 because we're at full employment. So the left-hand side is 200. 100 times 2 is 200. So if you divide both sides by 50, you see, 200 divided by 50 is 4. So that means the price level is also going to double. It's going to be 4. See? So that's what this simple theory is saying. There's a one-to-one relationship between money supply and price level. If you double the money supply, price level is going to double. Okay. Let's do one example. That means if you decrease the money supply, price level will also decrease by the same proportion. It goes either way. If the Fed had decreased the money supply, say from 50 to 25, that means that you cut the supply of money in half, then price level is going to be cut in half from 2 to 1. So it goes either direction. Okay. You can do that such example. If suppose what I am, let's say suppose initially M was 200. Let's pretend, and let's say velocity was 2, and let's say output was say 200 and price was 2. So you can see initially you got MV equals to PY. M is 200 here times velocity, which is 2, must equal to price is what? 2 times Y is what? 200. So you can 400 equals to 400. Okay, now let's suppose the Fed cut the money supply in half reduce the money supply back from 200 to 100. So if M is now 100 instead of 200, what would be the price level? So you're going to use the same formula, say MV equals to PY. Remember, velocity remains constant according to this model. It doesn't change. So we're assuming that velocity will remain at 2, it's not going to be affected, and output is at full employment. It remains at 200. So the Fed has cut the money supply from 200 to 100. So this is 100 times velocity is 2 must equal to, we want to solve for the new price. Output is remain at 200. See that? See, if I divide both sides by 200, left-hand side is 200. 100 divided by 200. So 200 divided by 200 is 1. So price level is going to be equals to 1. See, price level also going to be cut in what? In half. So there's a one-to-one relationship between money supply and price level, according to this simple theory. Okay. So now having said that, I want us to go and start talking about how can I calculate how do we derive the classical money demand function from this simple model? Okay, we're going to derive, and by the way, so one thing I want to make very clear, when we economists are talking about money demand, that you are demanding money, the demand for money is analogous to holding money. Like if you have like $300 in your wallet, in your purse, okay, we're saying that's the demand for money. So the demand for money is equivalent to holding money. So we want to show what the classical money demand function will look like in that case. Okay. So let me open a new slide here, and we talked about it. For some reason this slide is tiny. Okay. So we are going to be deriving the classical money demand function. It's just a few steps. Just bear with me. So the first step is going to say, when we say MV equals to PY, we can divide both sides by V. So the left-hand side, the V is going to cancel. So that means my M is going to be equals to 1 over V times PY. Because you can write that like that. PY divided by V, you can write as 1 over V times PY. And since we're assuming that velocity is constant, if velocity is constant, then 1 over velocity must also be a constant. A constant is like a number 5, like 10. So when you say V is a constant, because that's what the assumption is, then 1 over V must also be a constant. If V is 5, and you're dividing 1 by 5. 1 over 5 is also a constant. It's a constant number. So if velocity is a constant number like 5 or 2, then the inverse of that velocity is also a constant. And we're just gonna say, since we're gonna use that, we're gonna say let what? 1 over v, which is a constant, be equals to some constant k. Constant. Okay? Because v is a constant, 1 over v must be a constant. And then remember, we just say that m equals to 1 over v times py in the previous slide. So if 1 over v is a constant, we're just going to say m is going to be equal to little k times py, because little k is what? 1 over v. For some reason my slides are really tiny. I ran out of room quickly. That's what happens when you share a screen at Zoom. So I gotta be making these little slides all the time. It's going a little bit inconvenient, but that's okay. So we have we're saying m equals to 1 little k py, because little k is 1 over v. It's a constant. Okay? Now, I want you to think for a second. This is the total money supply in the economy. The money is like there's a market for money. We call it the money market. Anytime you talk about markets in economy, markets have the demand side and a supply side. So if this is a total supply of dollars in the economy, then we're going to say that let M with a subscript D be what we're calling money demand. I remember I said the demand for money or money demand is the same thing as money holding. So that means in equilibrium, the money market is going to reach equilibrium when the total supply of dollars in the economy must equal to the total demand for dollars. That's true. In equilibrium, you know, when you reach equilibrium for something, supply equals to demand. You know that from your baby economics class, your 2315 class that you took already. Okay. So once we invoke the money market equilibrium condition, then we can rewrite this formula. Instead of where is M, we're going to replace it with D, because we're assuming that if the money market reaches equilibrium, money supply equals to money demand. So we replace M with D, with MD. Okay, so that means so we're saying that since M equals to M to the D, then that means the money demand MD must equal to little k times PY. This is what we are going to be calling the nominal classical money demand function. And this makes a lot of sense. It's saying that, because remember, k is a constant. K doesn't change because k is 1 over v. When v is a constant, 1 over v is a constant. That's why we replace it with k. So that means the amount of money that people want to hold or people want to demand in the economy depends on two things. It depends on the price level and on real GDP. And that makes sense. And you can see that they are positively correlated. So that means if price level in the economy is rising, Americans are going to demand more dollars to go shopping. That makes sense. So demand for money is going to increase when prices of goods and services are rising in the economy. It's like, think about it. If your family typically buys something for $100 at H-E-B, the grocery, you go in, let's say $200, you know, you shop for a week, $200 for groceries, or $300. Okay, so that means if the prices of those goods in H-E-B goes up on you, on your family, that means your family will need more dollars if they want to buy the same amount of goods and services they were buying with what? With $300. They probably might need $500 this time around because things have become expensive, see? So anytime prices of goods are rising in the economy, people are going to demand more dollars to go shopping. And the converse is true. If prices are falling in the economy, then we don't need a lot of money to go shopping. Okay, so the demand for dollars is going to fall when prices fall in the economy, and it's going to rise when price rises in the economy. So that's why, so there's a positive relationship between price and money demand. There's also a positive relationship between output and money demand. So if the economy is producing more output, there's plenty of goods being produced, then we Americans are going to demand more dollars to go shopping. That's right. That makes sense. Because think about it. If the economy is producing more GDP, what does that mean? It means most Americans have jobs. They're working, means the economy is healthy. The economy is doing good. So if the economy is doing good, there's more GDP, that means more income, because you can also call this real income or real GDP. It means higher income in the economy because people have jobs when we are producing more output. So if people have more income, they're most likely going to demand more dollars to go shopping. So if GDP falls, means the economy is weak, means many Americans don't have jobs, their income falls, then we're not going to demand a lot of dollars to be shopping when there are so many unemployed Americans who don't have income. Okay? So there's a positive correlation between real GDP and money demand as well. Okay? Okay, so now one thing that in economics, while we are calling this nominal money demand, when you say nominal money demand, it means it's in dollar terms. Okay? In economics, we have nominal variables. We tend to distinguish nominal variables from real variables. So if I ask you that how much money do you earn an hour from your place of work? Somebody may say they earn $50 an hour or $100 an hour. So that should be a pretty good job. If you get $100 an hour from your job, and somebody asks you, what's the price of lunch if you go to eat lunch? Somebody says $20. Okay, so I want you today to start thinking like an economist. If you're earning $100 an hour, you don't look at the amount of dollars that you are earning per se, but you look at it in terms of how much that $100 can buy you. That's what we call the real value of the dollar. The real income is the amount of goods and services that your $100 can buy you. So if lunch is $20 and you earn $100 an hour, that means your real hourly earning. When I say real hourly earning, means the amount of goods and services that $100 can buy you. That means $100 is going to buy you $100 divided by 20 can buy you 5 lunches. So somebody just say, when I say, what's your real income? You're going to say, my real hourly income is 5 lunches. That makes sense. That basically you're telling somebody the amount of my hourly income that can buy lunch is $100. I can buy 5 lunches with what? With $100. Okay. So that's what we're going to talk about that in terms of money too. So let me open a slide here. I will talk about the other side again. So as I talk about in economists, we only have what we call real versus nominal variables. So if we say MD is nominal money demand, then if we divide that MD by price, this is what we are calling the real money demand. It's no longer in dollars. It will be the actual amount of goods and services that the total amount of dollars that Americans are demanding, which could be in trillions of dollars for everyone in the economy, okay, can buy us. Okay, if we divide MD by P, that's what we call the real money demand. So that means since we already derived the formula for the nominal money demand, we're just going to do a little bit of algebra manipulation to it, and we're just going to get the real money demand. Okay. So what do we do? What did we derive as our nominal money demand? We said MD from the previous slides equals to PK P times Y. So if I divide both sides by P, see on the right-hand side, the P is going to cancel. So that means the real money demand function, the classical real money demand function is MD over P, is just going to be equals to little k times Y. See, K is a constant. So now, because Y is basically what? the actual amount of goods and services that our money can buy us. So the real money demand is going to be constant K times Y, meaning that if GDP, if the economy is producing more output, real money demand is going to increase. Okay, so that's a classical money demand function. Very simple. Do I have any questions so far? Daniel? Emily? Ryan? Can you guys hear me? Can you guys unmute your microphone when I call your name? Hey, Ryan, are you there? Can you hear me?
Yeah, I can hear you. Can you hear me?
Yeah, I can hear you. Yes, yes. Because I want to make sure that we are all on the same page. Yeah. John Barning there? John, can you unmute your microphone, please?
Yeah, sorry, I'm here.
Okay, okay. I just want to make sure that everybody can, if you guys cannot hear me properly, please let me know, because sometimes we can have a microphone issue, and you guys be engaged. Yes, if I'm going too fast, when I'm teaching on Zoom, I try to make the class as interesting as I'm teaching in person. They say I have my digital pen, but even though my writing on the computer screen with a digital pen looks like chicken feet, but at least you can what? You can follow what I'm talking about here. Okay, and I hope you guys bear with me on that. But so you just stop me, ask me any question, just like you normally do when you're in the actual classroom. If I'm going too fast or something, you did not get something correctly, you want me to slow down and explain it for you, please do. Okay, because this is like we're in person. That's why I try to make it as engaging as I can possibly do. Okay. All right. So we talked about this already. So so this is we already talked about derivation of this classical money demand function. So now what I want to do next, I want to talk about the model of inflation, how we can use this quantity theory to derive a formula for inflation. Okay. So and again, I'm gonna step by step, So now when you think about it this way, when we write this formula, this is gonna take me time to better one here. This one's okay. Just hold on a second, guys. Okay, so when we write the quantity equation like MV equals to PY, this is what we call level equation. Each of these variables are in level terms because M, you can define M as level of money supply. You see that? You can divide V as level of velocity. You can define P as price level, see? General price level. And then Y is a level of what? Level of GDP or level of output. But remember, as economists, we are not only interested in just a level of something at a point in time. We're also looking at the growth rate. We want to look at the growth rate, the percentage change in something. For example, if you went to the mall this morning and somebody wanted to buy like a beautiful pair of shoes, and the guy at the mall tells you that, hey, the shoe is $100 today. Isn't it's also it's going to be also in our own interest to figure out how the price of that shoe has been changing for the last month, the growth rate, the percentage change. So when somebody say, oh, the price of the shoe at the mall is $100 a day, somebody could also ask the question, what is the percentage change in the price of the shoe from yesterday to today? Because the guy at the mall, the owner of that shop keeps changing the price on that shoe. So now we can, and you guys know how to calculate the percentage change on something. Okay. So For example, if I have M, the value is M at time T. T stands for today. And then I'm gonna have a value of M yesterday. When I say T minus 1, means today minus 1 period. That means like yesterday could be 1 week ago or 1 month ago or 1 year ago. Okay? So if somebody asked me to calculate the percentage change or the growth rate of money supply, so the growth rate, you guys know how to calculate growth rate. Growth rate or percentage change in M. So you're gonna go, you take the total money supply today minus the value of money supply yesterday or last year or last month, MT minus 1, divided by the amount of money yesterday. And then you multiply this by 100 because you want in percentage. Okay? And you can write this, if you take the time notation out, this can be written as because MT minus 1, that's a change in the money supply. The numerator is a change. And the notation for change in economics, we always use the Greek letter, the alphabet delta. So the numerator can be delta M. Then you divide by M. This is a percentage change. If you want to write it in percentage, we can just say percentage change in M for short. And you can do that variable by variable. You can also do, say, what has been the change in the price level of through time. So if you go, you do the same thing for price. You want to convert price level into percentage or growth rate. So you do the same thing. You ask yourself, what was the price level in the economy today? And what was the price level in the economy last year or last month? So the percentage change in the price level, you take the price today minus the price yesterday or 1 period ago, divided by the price 1 period ago. And again, this is going to be equal to delta P over P, which in short, you can just write it as percentage. This is a percentage sign, right? Change, delta means change in P, just for short. So you do that the same for all variables in the system. So we can also do that for velocity. So if you say VT today, VT yesterday, so velocity, change in velocity can be VT minus 1 divided by VT minus 1, which is just going to be equal to delta V over V, which you can write it as percentage change in V. Okay? You do that over and over again for all the variables. Then the last variable in that model, we have 4 variables, is GDP, real GDP, or output, Y. Okay, so let's do that. So you have YT today, and you have YT 1 period ago. So the percentage change in output is going to be YT minus 1 divided by YT minus 1, which is the same thing as delta Y over Y, which for short, you can write it as percentage change in what? In Y. Okay? So now that's how you express variables from growth rate, from what? Level to growth rate. Because we're also interested to know. Okay, so now there are mathematical rules of taking percentage change. So I'm gonna, I want you to remember this because we're gonna repeat that going forward. So we can talk about the rules of percentage change. Or you can say the rules of what? The growth rules. Mean the same thing. So the first rule is what we call the product rule, which we're going to apply today. The product rule of percentage change. The product rule says that if you're taking the growth rate or the percentage change in a product of 2 variables, percentage change or growth rate in like the product like X times Y. Okay, that's why we're calling the product rule, because product means you're multiplying 2 variables. It could even be X, Y, Z. You can have 3 variables. So the percentage change in a product of 2 variables, X times Y, according to this rule, is approximately equal to, its approximation is going to be the same thing as percentage change in X plus percentage change. You split them by addition. Percentage change in Y. That's one rule, product rule. The second rule, which we're not going to apply today, but we may apply in a near future, in other topics, is the quotient rule of growth. So second rule, mathematical product rule, rule of growth or percentage change. You call it the what? The quotient rule of percentage change or of growth rate. Because percentage change is the same thing as growth rate. Okay, so if you're taking the percentage change or the growth rate of a quotient means you're dividing. So the percentage change in a quotient like X divided by Y. See, that's what they call a quotient. This is going to be approximately equal to, it's going to be the same thing as the percentage, you split them by subtraction. So it's going to be the percentage change in the numerator, which is X, minus the percentage change in the denominator, which is Y. So those are the rules of growth rate. So now let's go back to our case. So our case, we're saying that we're going to start from the quantity equation, right? Oops, what are you doing? Okay. So remember, we're saying that so now we know that MV equals to PY. You know this already, the quantity equation. So an equation, what you do on the left, you must do on the right. See, if I say, take the growth rate of both sides, take the percentage change of both sides of this equation, of both sides. So that means you're going to say percentage change in M times V, in a product of two variables, M times V, must equal to percentage change or growth rate in P times Y. Because P times Y is on the right-hand side variables. Okay? So an equation, what you have done on the left, you must do on the right. So we just took the percentage change or the growth rate of both sides of this quantity equation. Okay, then now we are going to apply the product rule of growth rate, which we just learned. We say that the product of two variables that are multiplied each other, product of two variables, you split them by addition. So that means the left-hand side of our variable here is going to be, let me open my slide here. Okay. So that means the left-hand side, which is percentage change in M times V, you're going to write that as apply the rule of growth, percentage change in M plus percentage, you split them by addition. That's what the rule of growth says. Percentage change in V must equal to the right-hand side, and the right-hand side is also percentage change in a product of two variables, P times Y. So we're also going to split it by addition. So that's going to be equals to percentage change in P plus percentage change in Y. Okay? So now we know how to write these equations in what? This equation in the short form. Okay? Because I say if you get the percentage change in Y, we did it here. Okay, V, see, percentage change in M, we're just gonna use this sign here, percentage change in M. So if you come here, this basically means, so we're gonna say percentage change in M, the notation is what? You just write percentage sign delta M. Okay, plus percentage change in V, which you're gonna write percentage change in V, must equal to the right-hand side, which is percentage change in P, which we're gonna write in for short is percentage change in P plus percentage change in Y. But remember, we said in the beginning, one of the assumptions of this model is that velocity is a constant. So if something is a constant is like 5. If it's 5, 5, 5 every period, the percentage change in a constant is 0. You know that. So since velocity is constant, since V is constant by assumption, then that means percentage change in V is gonna be 0. Okay, so now since V is dropping out from our expression, so we can now rewrite this equation. Okay, we can write this, it's a percentage change in M, that's gonna be written as percentage change in M plus percentage change in V, which is now 0. So this is 0. So that means we're just gonna be plus 0, which is, so equal sign, right-hand side, percentage change in price, so that's just gonna say percentage change in P plus percentage change in Y. So I want to make P the subject, make percentage change P by subtracting percentage change in Y from both sides. If I subtract percentage change in Y from both sides, you can write this as percentage change in P must equal to percentage change in M minus percentage change in Y. Okay? What name do we give for percentage change in a price level? Ryan, Daniel, Emily. What is the economic name for the percentage change in the price level?
Is it the growth?
The percentage change in the price level is inflation. You guys know that, right? When the general price level in the economy is going up, that's what we call inflation. Okay, so inflation is defined as percentage increase in the general price level. If the price level decreases instead, that's what we're going to be calling deflation. Deflation is the opposite of inflation. If prices in the economy are falling, we call that deflation. But when prices are rising in the economy, we call that inflation. And our notation for inflation from today going forward, we're going to notate inflation, whether deflation or inflation, we're notating it by what? Pi. So pi is my notation for inflation. Then we can write the formula above now, because percentage change, since percentage change in the price level is what we call inflation, we're just going to say the last equation is going to be written as what? Inflation, which is pi, notation for inflation, equals to percentage change in money supply minus percentage change in what? In output. This is a very interesting equation that we have just derived. This is the equation for inflation, or the model of inflation that economists use to predict inflation. Equation for inflation. It says that inflation pi equals to the growth rate in the money supply minus the growth rate in output. Okay, so the idea here is that, because you always hear people say that, even during the Biden administration, that Biden, because we dump a lot of money in the economy to bail the economy from COVID. We had COVID-19, the pandemic. So the government had to print a lot of money, dump a lot of money for vaccine distribution, making sure that Americans had the vaccine for COVID. We bail out companies that were collapsing because we're in lockdown. We send checks to Americans during COVID. So all those money that came to the economy, the result was what we are still paying for that up to today. That's the reason why you see prices at HEB everywhere have gone up. Things have become very expensive. So the idea is that if you increase money supply, The result is inflation. Okay? So this equation is saying that if the central bank allows money supply to increase, let's say at 6%, the rate at which you're printing money, but let's say the economy is growing because the percentage change in output, that's the growth, that's how much the economy is growing. The growth rate in the economy, what they call economic growth, is measured by the percentage change in real GDP, in real output, how much we are producing. So the idea is that if you allow the money supply as a central bank to grow faster than the rate at which the economy is growing, you end up with inflation. And that makes a lot of sense, you know. Okay, so because what did we say the layman's definition of inflation is? If your grandpa or your uncle who might not have taken economics, but maybe they're engineers, they're scientists, they never took economics because they're in the same a different profession, ask you that, hey, Daniel or Emily, I know you took economics at Texas State. What is inflation? You can tell your grandpa that inflation, in a layman's term, is too much money chasing too few goods. Yes, that's a layman's definition of inflation. Too much money chasing too few goods. When you allow the money supply to grow faster than the rate at which the economy is producing output or goods and services, the result is inflation. Let's do an example there. Let's say suppose the central bank, the Federal Reserve, allow the money supply to grow at say 5%. But the economy is growing at the rate of only 2%, the rate at which the economy is producing output. And then so that means we know that the formula for inflation, say pi equals to percentage change in what? In money supply minus percentage change in what? In output. So that means inflation is going to be equal to 5% minus 3%, no, 2%, which is going to be 3%. The economy is going to end up with 3% inflation. Okay? So what does that mean? So when we write the formula for inflation like this, that means we can talk about what causes inflation. The primary cause of inflation in the economy, why things become expensive in the economy. So when we say pi, which is inflation, is percentage change in money supply minus percentage change in output. That means there are two causes of inflation. Two primary causes of inflation. The first one is what we call demand pull inflation. I'm going to explain what this means. Demand pull inflation. This is inflation. This is caused by excessive increase in the money supply. Because think about it, this is the same thing that I told you guys. When I was a little kid, when I was a 7-year-old kid, my dad used to be a teacher too. So I used to walk with my dad in this poor neighborhood, and I would ask my dad that, why is this neighborhood so poor? Why can the government just print money and distribute it to this neighborhood, maybe drop money from the sky with a helicopter? So every household in this neighborhood would be $10,000, $20,000 richer. And then my dad would look at me, I was a 7-year-old asking so many questions, told me that would be a very bad idea. So I asked him why. Then he just told me to shut up because he thought I was too young for him to start explaining to me the concept of inflation. Okay? So the idea here is that when the government is printing too much money, think about if we all get money. Let's say we wake up tomorrow and the government sends us a check of $5,000. Every Texas State University student or everyone in America gets $5,000. What do you think they're going to do with it, Ryan? If everybody is $5,000 richer tomorrow or $10,000 richer? Daniel, what would Peyton, what's the problem with that?
The price of everything else would increase.
Yeah, because that's right. Everybody's gonna go with that $10,000 they've received from government. They want to buy stuff. They're gonna put up an upward pressure on what? On the demand for goods and services. And that's why we're calling it demand pull inflation. When there's too much money circulating in the economy, it tends to increase aggregate demand for goods and services, and that ends up driving prices of goods and services, causing inflation. That's why it's called demand pull inflation. So it's this first part. Okay, and that demand pull inflation can be the Federal Reserve printing money or government spending too much government money, government spending. Okay, the second cause of inflation is the second part of the equation. So the government may not actually print money, but we can still end up with inflation. I'm going to explain that. So so the second cause of inflation is what we call cost push inflation. So this is due to low productivity. Or you can say the economy is producing what? Less GDP, less output, producing less output. We say we are less productive. So that means that's why you see there's a negative sign on this formula. Minus percentage change in what? So the government may not print money at all, but we can still end up with inflation. Why? If the economy is not producing enough output, let me ask you, Peyton, if you go to a supermarket in Austin or in San Marcos, and because the economy has not produced enough bread, let's say you go to a major supermarket in downtown Austin where people normally shop, and there are only 10 loaves of bread available on the shelf. What do you think the price of those bread is going to be?
It's going to be super high.
That's right. So that's inflation being caused by low productivity. If the economy has not produced enough output, where we go to the stores, let's say we wake up tomorrow and we go to Walmart, we go to because that's one thing that is scaring me with especially this tariff war that is going on, because we buy most of our products from China, and some people were saying that going into the summer, if this trade war continues, we may end up with empty shelves easily. Where you go to Target to buy something or to Walmart, there's nothing on the shelves. So, or very few things are on the shelf. People are fighting for those few things. The price are going to go up. So inflation can be caused by demand. And you could think about you can now broaden this discussion and think about critically, what could possibly make an economy not produce enough output? So you could expand your discussion and say things like maybe supply chain issues. Like, since during COVID, because China shut down its economy, American companies, we get a lot of raw material goods coming from places like China, India. But because China was in lockdown, it brought a lot of supply chain issues in the economy. So the inflation that we have up to today, which is things are still very expensive, was actually not only due to the government printing money, but also due to supply chain issues that came with COVID-19, the pandemic. Okay, so those are the two primary causes of inflation that this simple model can teach us. Any questions so far?
No.
Okay, good. So you can literally see that so we have derived the model for inflation here. See, that's the equation that we talked about. But because velocity is 0, then this is a final equation here. Okay. All right. So now let's go a little bit deep into the topic here. So now let's look at the evidence, because this simple model is saying that countries that print a lot of money, okay, relative to how much the economy is growing, end up with higher inflation. Okay. So let's look at the evidence. Let's start with the United States first. See this graph. The graph on top is the United States. So there are times when American government, so on the vertical axis, we are measuring the rate of inflation. And then on the horizontal axis, we are measuring what? Money growth, which is basically what we call percentage change in what? In money supply. So you can see in the 1970s, okay, the government allows the money supply in America to grow at a much higher rate. You can see growing at around money supply was growing at around 11 to 12%. So we ended up with very high inflation in the 70s. There are times when, like in the 1950s, money supply was growing at a much lower rate. we also end up with low inflation. And then there are times when we allow the money supply to be negative. Like in 1870, the Fed, the government was cutting the supply of money in the economy. We ended up with deflation. See, negative inflation means deflation. Deflation means prices were actually falling around that time. So if you fit a line here, this line is most likely going to be upward sloping, meaning that there's a positive correlation between money supply growth and inflation, the rate of inflation. So the vertical axis is rate of inflation, which is pi. Okay, what about international evidence? So let's look at this graph on below here. International evidence is saying that countries that print a lot of money tend to end up with what? Inflation relative to the growth of their economy. Look at a country like Turkey. So between 2009 and 2019, the Turkish government allowed the supply of the Turkish lira, the Turkish money to grow at a rate of about 19%. That's the rate at which the Turkish government was printing money. See that? And then they ended up with very high inflation of about close to 9%. See? So there's even international, but there are counterfactuals here. I want to ask you guys a question. Why is it that you see there's a counterfactual here? If we are saying that printing money results into higher inflation, look at South Africa. South Africa, compared to the rate at which South African government was printing their money, the South African money is called the rand. So the rate at which the South African rand was growing at a rate of about 7%. And yet South Africa ended up with higher inflation than Turkey, even though Turkey was printing money at a much higher rate than South Africa. So what could be the reason why? Because if we are saying that printing money causes inflation, why is it that even though South Africa did not print a lot of money compared to Turkey, Russia, and Brazil, South Africa ended up with a much higher inflation? What could be the reason? Ryan?
It's low productivity or
Exactly. That means it could be that even though South Africa did not print a lot of money, maybe the economy was not producing as much output. There was low productivity. There were very few goods produced in South Africa. That's the reason why they ended up with a much higher inflation. So meaning that maybe there were two problems going in South Africa. Government was printing some money, and also the economy being having low productivity. So that could be the reason. Thank you, Ryan. Okay. So these are more graphs here. If you look at the rate of money, this is for the United States. The rate at which the Federal Reserve has been printing money since the 1960s or more recent time. You can see there pretty much high, very good correlation between money supply growth line is a red line, and then the blue line is inflation. No, a high money low inflation. There you go. So, okay. Okay. So we are going to be talking about something else now. Budget deficits and inflation. There's a relationship. Okay. So there are two ways that the government can pay for spending. If the government, let's say the U.S. government wanted to, let's say they raise $4 trillion in tax revenues, but they want to spend $5.5 trillion. They want to spend more than they have in tax revenue. There are two ways that the government can raise revenue. If they want to spend a lot of money, they can either raise your taxes, so they collect more taxes to pay for government activities, or the government can go into debt by issuing bonds. If they don't want to raise your taxes to pay for its spending, the government can borrow money by issuing what? Treasury bonds. That's how the U.S. government typically finances what? Its spending, its deficits, budgetary deficit. The problem is some countries have a third option. We don't have that in America. Some countries, especially third world countries, developing nations, they tend to, they may not be able to raise taxes, but their government might want to spend more money that they don't have. And then they cannot issue bonds either because maybe their bond ratings are very low. Nobody wants to buy those bonds. So the third option is government can just print money. Something that we don't do here. Like you go to a country where they might print money to build a road. But we have just established that when you print money, that you end up with inflation. So I'm going to write what we call the government budget budget model here, or the budget equation, budget constraint. Okay, we can call this a budget equation. I'm going to write down here, budget constraint, or the budget equation. Okay, so the budget equation is, we know that T stands for tax revenue minus government spending. Okay, so if this is, oh, sorry. What do you do? Go back here. Let me go back. Okay. So T minus G, if this is less than 0, that's what we call a budget what? A budget deficit. G stands for government spending. T stands for taxes, tax revenue that the government has collected. G is government amount that the federal government wants to spend. In America, there have only been 3 times when we have had a budgetary surplus since the 1950s. Can you believe that? Only three years since the 1950s. That's why the national debt is at $36.5 trillion. So every year the government spends more dollars that they don't have in revenue. So in other words, our tax revenue is always short of what? Government spending. That's why this T minus G is less than 0. That's the definition of budget. So the question is, how does a government finance its budgetary deficit? So I'm going to write a constraint here. So we're going to say deficit, which stands for T minus G, okay, can be financed by the government, can allow for what we call change in bond holdings. I'm going to explain this, plus change in the monetary base. Okay. Plus you could add maybe change in tax revenue. So there are 3 ways that a government can finance is what is deficit. One is, this is going to be delta beta, means change in what? In bond holdings. The government is going to issue treasury bonds, borrow more money by issuing bonds. So there's going to be a change in bond holdings. This is issuing debt. B, the second one here is, this is change in what? You can define this as change in money supply or change in monetary base. Money supply. We'll talk about monetary base later. It's related to money supply. And then delta T is changing your taxes. Okay, so here's the deal. If a government wants to get rid of the deficit, how does a government finance its deficit? They can borrow money, that means they're issuing bonds, or they can print money, that money supply goes up, or they can allow taxes to go up. So if they allow your taxes to go up, or they issue debt, that is going to lead to no change in what? No change in money supply, in inflation. Because remember the equation for inflation from the previous slide, we say that inflation equals to percentage change in money supply minus percentage change in what? In real GDP. So if the government issues debt, issuing treasury bond, you see there's no bond holding here in this equation. So money, that means inflation is not going to be affected. If the government raises taxes to close its budgetary deficit, so that they can spend and close the deficit, that taxes do not enter in this equation. It will have 0 effect on inflation. The only time that the government can cause inflation is when they print money to finance their deficit. When monetary base on money supply goes up. So the change in the money supply is going to lead to inflation. Okay? So the government budget constraint reveals 2 important facts. One, if the government deficit is financed by an increase in bond holdings, that means the government is issuing debt, there's no immediate effect on the monetary base and hence on the money supply. So the inflation is not going to be affected. But there's what we call monetizing the debt. If the budgetary deficit is financed by increased bond holdings by the public, the monetary base and money supply will increase. See that? Okay, that could be problematic down the road. Okay. So modern monetary theory argues that the Green New Deal, you guys talk about, the Democrats have been singing about the Green New Deal, like, you know, AOC in Congress. If it's paid for by the government issuing bonds to fund large budget deficit for the new Green Deal, that could be problematic. You know, it can raise the debt. It could increase inflation in the long run. Okay. Okay, we're making good progress here. So then the other thing that I want to talk about briefly is hyperinflation, concept of hyperinflation. So hyperinflation is inflation that is so high where prices or inflation is going up at a rate of 50% per month. The United States has never experienced hyperinflation in the history of the nation's founding. We have not experienced hyperinflation. Hyperinflation have been in those countries like Germany in 1920s. Okay, why did Germany experience very high hyperinflation in 1920s? Germany was forced to pay reparations for war crimes during after World War I. So then the German government did not have money. They resorted to printing money. And that money led to very high inflation in Germany of more than 50% per month. Recent inflationary episode like this country that borders South Africa, Zimbabwe, in the 2000s. Inflation in Zimbabwe was increasing at a rate of like 50,000% per month. That's how bad it was. Okay, almost every country, you know, in developing country has experienced some form of hyperinflation. But the United States, as an advanced economy, has never. Okay, so many economies, both poor and developed, have experienced hyperinflation over the last century, but the United States has been spared of such turmoil so far. So we are very lucky. Okay, so that's hyperinflation. When you see prices are rising at a rate of 50% or more per month, that's what we call hyperinflation. Okay, and as I said, we have never experienced hyperinflation in the United States. The hyperinflation typically is the idea that the government is excessively printing money, you know. Too much money, printing of money in the economy can cause that. Any questions so far?
No, no questions.
Okay, so we're making good progress. Okay, so now up to this point, we have concluded our discussion about the classical theory of money demand. We derived the money demand function again for the classical theory. Remember that money demand function, which was what? MD. When we derived the classical money demand, the nominal, it was MD equals to little k py. And then this was in nominal terms. In real terms, we divided by both sides by p, or you can write this as MD over p equals to just little k y. Remember we did this. Now we're going to be talking about the money demand function by Keynes. John Maynard Keynes developed a theory of money demand when he wrote his book in 1936. The title of the Keynesian book was A Theory of Money, of Interest, Income, and Money. Okay, Keynes, John Maynard Keynes is a British economist. He's from the United Kingdom. Okay, so let's talk about the Keynesian theories of money demand. So we also call it the Keynesian preference, liquidity preference theory. So you could just call it the liquidity preference theory. You can call it the theory of what? The theory of money demand. We call it the Keynesian preference theory. So this is developed by what? John Maynard Keynes. In his 1936 book. Okay, so Keynes began by asking a simple question: that why do people hold money? Why do you keep dollars at home? I don't know how you guys keep your money at home, maybe in a piggy bank at home or in your purse, your wallet. I may tell you that maybe I dig a hole in my backyard and store my money. I'm just kidding. But so when I talk about money demand, this is money that is outside of the banking system that people are holding. Why do people hold money? Keynes argues that there are three main motives why you owe money. If I ask Emily, I say, Emily, how much money do you have in your purse today? Emily's gonna say, I have $100. And then I ask Emily, why? Why you hold $100? Emily might tell me, hey, I'm actually going to the store to do grocery shopping, or I'm going to the mall to do. So Keynes argues that the reason why people are holding money is because they're going to use it for transaction. They're going to for spending. So that's money serving a purpose as a transaction motive. You hold money because you're going to spend it on goods and services. That's a transaction motive for money. And then I may ask Peyton, why are you holding money? And then Peyton is going to say, well, I hold this dollar sometimes because I want, what if something, maybe the price of goods in the mall drop unexpectedly? If I have ready money, I don't put this money in stocks. I have money, I can take advantage of that unexpected drop in the price of electronics, like during Black Friday. Because because if you invest all your money in the stock market and Black Friday comes where things are 75% off, then you can't go to Best Buy on a Black Friday and tell people that, oh, I have money in stocks, give me TV. You know what I mean? You need to have ready money to buy that TV. So Peyton is gonna say, I'm holding this money just to take advantage of the unexpected drop in the price of goods and services, so that I can take advantage and buy it with cash. Or it could just be precautionary. It could also be that you're holding money to take care of the unexpected. Maybe you can anticipate something bad can happen to us. Maybe you get sick of something, you need money, or your car may break down. You need money to what? To take care of that. That's precautionary motive. And then the third motive is speculative motive. That's Keynes arguing. Keynes argues that people need money for speculation purposes. Maybe you want to invest in stocks, you want to invest in cryptocurrency, okay? And then Keynes is going to distinguish between real and nominal quantities of money. So we're going to say, if you have if this M is going to be what we call nominal quantities of money, which is in dollars. That's right. So if I ask you what is the nominal money supply for the United States, the total amount of money that Americans are holding, somebody could, if you sum everything, maybe it's $3 trillion. Okay, but Keynes also talks about real money, real quantity of money. So if you divide M by P, by the price level, this is what we call the real money supply. Okay, so we have, let's say, $3 trillion in the economy that is circulating among Americans. And if, let's say, the general price level is 1,000, if we divide that 3 trillion by 1,000, that gives us the total quantity of goods and services, or GDP, that we can buy with our money. So real means is in actual goods and services. This is in what? In quantities, quantity of goods. This is no longer in dollars. Okay, so we do the same thing on demand. Okay, so we're gonna say let me see. To escape this. Okay, so I want to say something like let's see, let me open my slide here a second. Okay, and then I'm gonna share the screen. Okay, so we're gonna do the same thing for money demand. So remember we said MD was the nominal what? Nominal money demand. So real money demand, we say if you divide MD by P, you get real money demand. Okay, so Keynes is gonna put interest. Remember in the classical theory that we talked about earlier, says that real money demand, MD over P, was equals, or only depends on real GDP because K is a constant. Keynes is going to put interest rate in the model. So the Keynesian theory, the Keynes theory of money demand argues that the money demand function depends on, it's a function of two things: interest rate, I, and real GDP. This in general. Okay? And this makes a lot of sense. Peyton, if I ask you a question, if I say, suppose the banks were paying 20%, this I is interest rate that banks could be paying on a savings account. Peyton, are you there?
Yeah, I'm here.
Okay. So if banks were paying 20% on a savings account, man, that's a lot of money, interest. Would you walk around with $1,000 in your pocket or keep money at home?
Say that one more time. You cut out. Sorry.
I'm saying if the banks were paying up to 20% on a savings account, if you deposit money in a savings account, you earn 20% on your savings. Would you walk around with $1,000 or keep the money at home?
Oh, I'd put it in the savings account.
You put it in savings. That's right. So what does that mean? Because remember, we're saying that money demand is the same thing as money holding. It's analogous to the amount of money that people are holding in the economy. So the key idea here is that if interest rates are high, the money demand is going to be low. People are going to hold less money because people want to invest money when interest rate is high, or when bonds, or if the return on stocks, the return on bond is very high. People are going to invest their money in stocks and bonds and hold less money. So there's a negative relationship between interest rate. We're going to put negative on top of this I. But there's a positive relationship. We've already shown that between what? Real GDP and money demand. When the economy is doing well, where there's higher income, real income or real GDP, people demand more dollars to go shopping. So there's a positive correlation between Y and money demand, but negative correlation between interest rate and money demand. Okay. Okay, but yeah, so I can expand on this. So this is how Keynes is going to write the money demand function in general. My pen is not giving up on me. You guys saw see the money demand function there? Okay, so there's one thing that we made assumption before in the classical model. We assumed earlier on that the velocity was constant. So Keynes is going to argue that once interest rate is affecting the money demand, velocity is no longer going to be a constant. Velocity is going to be procyclical to changes in interest rate. So let me show you. In the classical money demand function, there's no interest rate. Okay, so I want to share with you guys something. Just hold on a second. Let me open this. Okay, so let's see. I want to open this. Okay. Okay, so we know that so where could we know that M, oops, it's been giving up on me. What is it? Okay, so this is gonna be a problematic here. Let's see. Just one moment, guys. One of the things we encounter when we teach online sometimes. Okay. All right. So what is it? This pen is not working. Okay, but anyway, we got, I think I ran out of battery because I need to write something on the screen. We got 6 minutes on the clock. what I want to show was that I want to show using this equation that velocity is no longer going to be constant under the Keynesian framework. Velocity is going to depend on interest rate and the level of GDP in the economy. Okay, so the notion that velocity was constant, that was only a classical assumption, but under the Keynesian framework, velocity is no longer going to be what? It's no longer going to be constant. So when we meet tomorrow, I'm going to show you that. So velocity is not constant anymore. So the procyclical movement in interest rates will induce procyclical movements in velocity. Okay, yeah. So anyway, I'll pick up from there next tomorrow. And it's a fairly short chapter. There are only like 2 slides remaining, 3 slides remaining. So tomorrow, I want you to do me a favor. We're going to start talking about the time value of money, like present value. Very interesting. Present value, future value, calculating interest rate. So please have your, if you have a financial calculator, how many of you know how to use a financial calculator? Ryan, you have used a financial calculator before? Daniel, Emily, in your
I have.
Yeah.
Yeah, so if you have a financial calculator, have it available with you. Even if you don't have a financial calculator, just have with you a scientific calculator. I'm an economist, I'm not a finance guy. Because there's a tendency that when people know how to use a financial calculator, they just memorize, they press on a button, present value, future value, but they don't know what the math is, what is being calculated underneath that calculator. I'm going to show you a mathematical algorithm of the formula that got programmed underneath that financial calculator. And we're going to use algebra and regular scientific calculator to show that even if I don't know how to use a financial calculator, I can still get the same answer that the finance people are getting using a financial calculator. But using a regular scientific calculator. So have your calculator ready tomorrow. We're going to be starting talking about the time value of money. Very interesting chapter. So you learn a lot about the concept of present value, and we're going to apply that in regards to 4 main credit market instruments. We're going to talk about a simple loan, fixed payment loans, discount bonds, and coupon bonds. So, and then we're going to start to talk about how, if you invest in a bond, how do you actually calculate the rate of return on a bond investment? Okay, so I have everything ready tomorrow. So we're going to pick up from there tomorrow. Matthew on Spirits, finish this chapter, and then we pick up on chapter 4 tomorrow. All right, I'll see you guys tomorrow. Don't forget to complete if you are not in class last week, I signed homework 1 and quiz 1. So they are due tonight. If you didn't have a chance to do it over the weekend, make sure they are long. You need to start on it early. I think the homework 1 and quiz 1 expires by 11:59 p.m. tonight. So you just want to get on it right away. There's so many questions that I write on the homework and quizzes. If you are not in class, those some assignments are due online at my Conlab. Yes, at Canvas. We're going to be doing all assignments online at my Conlab. So you just click on, if you're not in class, if you open the class website at Canvas, you go to your class, you click on modules, and then you're going to see Pearson course material. You click on it, that's going to take you where you can take what you're going to see my Conlab assignments. Please, you're going to see those assignments assigned there. Okay, finish all of them. I'll see you guys tomorrow.
Have a good one.
Oh, you do. Bye-bye.
I just had a question real quick.
What was it?
When will you upload the test review?
That's gonna be probably I'm gonna do that because I need to see how much coverage of the material we have, because the test is Friday. So, but I would say it would not probably on Wednesday morning.
Okay, sounds good.
Yeah,
Thank you.
no problem. See you.